Okay, hi everyone, welcome back to this video series on cryptocurrency, diverging miners and difficulty. As miners diverge into mining two different chains, the hashing power is split between the chains. The mining power can be split in any proportion between the two chains. The new rules may only be followed by a minority or by the vast majority of the mining power. Let's assume, for example, an 80%, 20% split with the majority of the mining power using the new consensus rules. Let's also assume that the forks occur immediately after a retargeting period. The two chains would each inherit the difficulty of the retargeting period. The new consensus rule would have 80% of the previously available mining power committed to them. From the perspective of this chain, the mining power has suddenly declined by 20% vis-a-vis the previous period. Blocks will be found on average every 12 minutes, representing the 20% decline in mining power available to extend this chain. This rate of block issuance will continue barring any changes in hashing power until 2016 blocks are mined, which will take approximately 24.192 minutes at 12 minutes per block, or 16 8-point days. After 16 8-point days, a retarget will occur and the difficulty will reduce by 20% to produce 10-minute blocks. Again, based on the reduced amount of hashing power in the chain, the minority chain mining under the old rules will only 20% of the hashing power will face a much more difficult task. On this chain, blocks will now be mined every 50 minutes on average. The difficulty will not be adjusted for 2016 blocks, which will take 800 minutes or approximately 10 weeks to mine, assuming a fixed capacity for block. This will also result in a reduction of transaction capacity by a factor of 5, as there are fewer blocks per hour available to record transactions. Contentious hard blocks. This is the dawn of consensus software development. Just as open source development changed both the methods and products of software and created new methodologies, new tools, and new communities in its wake, consensus software development also represents a new frontier in computer science. Out of the debates, experiments, and tribulations of the Bitcoin development roadmap, we will see new development tools, practices, methodologies, and communities emerge. Hard forks are seen as risky because they force a minority to either upgrade or remain on a minority chain. The risk of splitting the entire system into two competing systems is seen by many as an unacceptable risk. As a result, many developers are reluctant to use hard fork mechanism to implement upgrades to the consensus rule. Unless there is near unanimous support from the entire network, any hard fork proposals that do not have near unanimous support are considered too contentious to attempt without risking a partition of the system. The issue of hard forks is highly controversial in the Bitcoin development community, especially that it relates to any proposed changes to the consensus rules controlling the maximum block size. Some developers are opposed to any form of hard fork, seeing it as too risky. Others see the mechanism of hard fork as an essential tool for upgrading the consensus rules in a way that avoids technical debt and provides a clean break with the past. Finally, some developers see hard forks as a mechanism that should be rarely used with a lot of advanced planning and only under numerous consensus are already we have seen the emergence of new methodologies to address the risks of hard forks. In the next section, we'll look at some soft forks and the BIP 34 and BIP 19 methods for signaling and activation of consensus modifications. Soft forks. Not all consensus rule changes cause a hard fork. Only consensus changes that are forward incompatible cause a fork. If the change is implemented in such a way that an unmodified client still sees the transaction or block as a valid under the previous rules, the change can happen without a fork. The term soft fork was introduced to distinguish this upgrade method from a hard fork. In practice, a soft fork is not a fork at all. A soft fork is a forward compatible change to the consensus rules that allows upgraded clients to continue to operate in consensus with the new rules. One aspect of soft forks, this is not immediately obvious, is that soft fork upgrades can only be used to constrain the consensus rules, not expand them. In order to be forward compatible, transactions and blocks created under the new rules must be valid under the old rules too, but not vice versa. The new rules can only limit what is valid, otherwise they will trigger a hard fork when rejected under the old rules. Soft forks can be implemented in a number of ways. The term does not define a single method, rather a set of methods that all have one thing in common. They don't require all nodes to upgrade or force non-upgraded nodes out of consensus. Soft forks redefining NOP opcodes. A number of soft forks have been implemented in Bitcoin based on the reinterpretation of NOP opcodes. Bitcoin script had 10 OP codes reserved for future use, NOP 1 through NOP 10. Under the consensus rules, the presence of these opcodes in a script is interpreted as a null potent operator, meaning they have no effect. Execution continues after the NOP opcode if it wasn't there. A soft fork therefore can modify the semantics of a NOP code to give it new meaning. For example, BIP 65 check time lock verify reinterpreted the NOP to OP code. Clients implementing BIP 65 interpret NOP 2 as OP check lock time verify and impose an absolute lock time consensus rule on UTXO that contain this OP code in their locking scripts. This change is a soft fork because a transaction that is valid under BIP 65 is also valid on any client that is not implementing ignorant of BIP 65. To the old clients, the scripts contain the NOP code, which is ignored. Other ways to soft fork upgrade. The reinterpretation of NOP codes was both planned for and an obvious mechanism for consensus upgrades. Recently, however, another soft fork mechanism was introduced that does not rely on NOP codes for a very specific type of consensus change. This is examined in more details in Appendix D. SegWit is an architectural change to the structure of a transaction which moves the unlocking script witnessed from inside the transaction to an external data structure, segregating it. SegWit was initially envisaged as a hard fork upgrade as it modified a fundamental structure transaction. In November 2015, a developer working on Bitcoin Core proposed a mechanism by which SegWit could be introduced as a soft fork. The mechanism used for this modification of the locking script of UTXO created under SegWit rules such that unmodified clients see the locking script as redeemable with any locking script whatsoever. As a result, SegWit can be introduced without requiring every node to upgrade or split from the chain. A soft fork, it is likely there are other yet to be discovered mechanisms by which upgrades can be made in a forward compatible way as a soft fork. Criticism of soft forks. Soft forks based on the NOP OP codes are relatively uncontroversial. The NOP pop codes were placed in Bitcoin script with the explicit goal of allowing non-distributive upgrades. However, many developers were concerned that other methods of soft fork upgrades make unacceptable trade-offs. Common criticisms of soft forks include technical debt, because soft forks are more technically complex than the hard fork upgrade. They introduce technical debt, a term that refers to increasing the future cost of code maintenance because of design trade-offs made in the past. Code complexity in turn increases the likelihood of bugs and security vulnerabilities. Validation relaxation. Unmodified clients see transactions as valid without evaluating the modified consensus rules. In effect, the unmodified clients are not validating using the full range of consensus rules, as they are blind to the new rules. This applies to NOP base upgrades as well as other soft fork upgrades. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.